pants. Now.
See who we're waiting on. So again, if you're just getting here and you haven't clicked on that Nearpod slide to answer your thoughts on that diagram.
Okay, time to say hi to everyone on here.
Oh, easy.
Hi.
Jayla's birthday is in 2 days.
So Josie, Betty, Josiah, Graham, Fallon, Mason, Ramita, Melis, Kylie,
Hey,
Ellie.
Evie, tell them about what you went to place on in 4-H.
Oh, no, I'd rather not.
Why?
I'd rather not.
Why not?
Not that big of a deal. Okay, my mom spent like an hour sending this to everyone she knew and everyone she had in her contacts, and I'm just like, is it really that necessary?
Well, the point is you won the contest that day.
Okay, yay.
Just saying.
Which 4-H?
Excited about probably
The
is like
4-H daily. Remember, the 4-H daily has daily contests you can enter.
Oh yeah.
Okay, if you have not joined Pear Deck yet, go ahead and do that. Joinpd.com.
But the one that I'm probably most excited about is the one with all the pictures, because now I'm going on to the state contest with my pictures. So I guess I'm a little excited about that.
I know Mr. Johnson, one of his students, won the contest yesterday where you did your messy room and then a picture after when you straightened it up, organized your room. We should do that, take before and after pictures and like clean up or organize a section of your room.
I mean, my room is already organized, so
yeah,
do I mess things
not
up?
everybody is you though, right?
Okay, yeah, you're probably right.
What are we talking about?
You never know, though.
All right, give you 30 seconds to join the Pear Deck. Please join if you have not already. Okay, we have almost every single kid in here. We're missing like 3 or 4 kids. All right. So again, joinpd.com. Quick yards, evaluate orange drums. All right. So really quickly review from yesterday. Will you on your Pear Deck response? And if you don't have Pear Deck, go ahead and text me your answer. What is the point of this drawing? Tell me what's important about this drawing. Again, send it to me on Pear Deck. If you don't have Pear Deck up, text it to me, please.
What's the question again?
Tell me what is the point of the two shapes in the picture? What is the drawing trying to tell you? Remind you. Angelo, will you talk about it in just a second? All right, so I'm getting from most people that we're looking here at the volume of the pyramid is 1/3 of the volume of the cube. What's the extra part of that we have to also include in saying that? Angelo. The pyramid and the cube have to have the same what's? You there, Angelo? So the pyramid is 1/3 the volume of the cube if they have the same what?
What would be a good spoken bitch?
You said that one more time? What'd you say? They have the same, I don't know, we having technical difficulties. Are you there?
Okay, do you want me to say it? I can say it.
Yeah, go ahead.
They have to have the same height and the same base.
And they have to have the same base. That's correct. So they have to have the same height and they have to have the same base at the bottom. So they have to have the same area of the base times the same height. It's just the pyramid's 1/3 of the cube's volume. So yeah, okay, let's move to the next slide. All right, let's quickly do a review of a couple of volumes. So if you will go ahead and give me the volume of this pyramid. And you will see the pyramid has a height of 6 inches and it has a base that is 10 by 8. So you know that means the 4 triangles would not all be the same. So the triangle that's here, back here, and the triangle that's over here would be the same, but the triangle in the front and the triangle around back would be a different size, but the same to each other, right? Because it's a rectangle on bottom. All right, so the volume, let's see, do we have, do I have a volunteer who would talk about the volume here? Eddie, will you talk about the volume?
Sure.
Okay, so what's the area of the base?
The area of the base is, hold on, 10.
10 times
Wait,
what?
I mean 80. 80, 10 times 80.
8, which is 80. And then the height is what? 6
inches.
And then I say, what? 80 times 6? And what you get for that?
80 times 6 is 480.
Okay, and then what do I do?
Divide that by 3.
Divide it by 3 or multiply it by 1/3, right?
Yes.
And when you do that, what do you get?
So 480 divided by 3. 480 divided by 3 equals 160.
Yeah, 160 what?
Inches. Wait, no, cubic inches.
Cubic inches, yeah. All right, just like that. All right, yep. All right, let's go to the next one. Next up, we have a volume of a pyramid, and you've got some different dimensions. One of those dimensions does not belong. Will you text me which measurement I do not need to use to calculate this? Text me which of those 4 dimensions would not be needed in the volume formula. Okay, so everybody's saying the 30 feet. That's correct, because the 30 feet is a side of a triangle, but it's not the right perpendicular measurement from the base. So this perpendicular measure of 24 is the actual height. So that's correct. The height is 24. So I would multiply 17.5 times 32, and then I would multiply that times 24, and then I would get 1/3 of that. Let me let Lincoln in. All right, so that's correct. All right, so moving on to the next one. Quick review of a trapezoidal prism. If you will give me the actual volume of this trapezoidal prism, would somebody remind us how we do that formula? Izzy, remind us how to do that formula, please.
Hold on. Okay, so the formula.
So I'm gonna take this and this and add them together, right?
Yeah.
All right. So when I do that, so for the base, I'm gonna say 12 plus 8. Right, Izzy? Times 10.
Yeah.
Okay, but I got to half the 12 plus 8, right? And that's going to equal 10. Correct?
And then, yeah.
Okay, so all of that becomes 100. Correct?
Yeah.
Everybody good with that? So the base area of this trapezoid is 100 because it's 12 and 8. Half of that's 10. 10 times 10 is 100. So now I want to know what the volume is. So if you'll send me what the volume is. And let me let Ashley in. Yep. So who are we missing? Nathaniel, Fred, Natalia. We got everybody else here? Just about. So I'm getting a lot of people saying that it would be 100 times 22. And that would be 2,200 cubic centimeters. So that's correct. It would be 2,200 cubic centimeters. So remember, it'd be 100 times 22, which is 2,200 cubic centimeters, right? All right. So now let's move on to the volume of cylinders. Okay, this was the picture that I gave you earlier, asking you to tell me what does this diagram have to do with understanding about volume of cylinders. And let me just read a couple of the things that people said. People said that it's still about cubic units. It shows you how much the volume can be when you put all the literal cubes in the shape together in there. It's the 3D shape, filling it with cubes. So yeah, so those are correct answers. That the point of that is that we're trying to show you that, let me pull my up. Okay, this soda can or this can of any kind is a cylinder, and it's literally about getting the area of the base, literally how many boxes of those cube units would be on the bottom floor times how tall it is. So it's literally floors in a building, right? It just happens to be this time it's a round building and not a square building. All right, so moving on. Here are some examples of cylinders. So they don't have to be like the one I just showed you. They can be really tall. They can be really round and skinny. The volume doesn't change how you get it. So it's about getting the area of the base times how tall it is. Okay, Dr. Parsons is going to show you on a can here. Here it is.
Where are you?
Right here.
Hi, guys. So look at my lovely chicken stock. My chicken bullet. Okay, you notice the can doesn't come up though. Look.
It's because I got that background on.
So never mind. There's going to be a fun.
There it is if you hold it in front of you.
Okay, so they're round on the base. Round on the base. There's the body. There's my lovely cylinder. Yay, 2 points for me.
2 points for you. Okay. So give me a guess. Here's what I want you to do on this. Okay. Give me a guess. Which of these 3 cylinders do you think has the largest volume by looking at them? So let me give you a name for them. Okay. So this is A. This is B. And this is C. So tell me, A, B, C, which one do you think has the largest volume? And I would love to hear from a couple of people about why. So we're going to be doing an activity where you're going to be making the Ooey Gooey Candy Company, and you're going to be defending which package is the best kind. And it's about the consumer thinking it looks like it's got more volume than it really might. Because, you know, that's what they do, right? How many people have gotten a bag of chips? Gotten a bag of chips, and it's like this tall, and inside the chips are only like up to here.
Yeah.
Right? So,
yes, that's so annoying. It's just
advertisers do that all the time. They want it to look like it's a really good amount of product for the way it's shaped. So shapes do make a difference, the way they're okay, so let me see what most people are saying. I'm seeing people saying C. Some people say B. I don't see anybody saying A, but I have several people saying they think they may all hold the same. So would someone care to talk about why you think C would be the larger volume? Why do you think C might be the larger volume? Who could talk about C? Y'all want me calling somebody? Melis, what do you think about C? Most volume or not? I think you said they would all be about the same.
Yeah, I said that they would all have the same volume.
Okay. Let me find somebody who said C. Well, I got mostly B's actually now. Did y'all change your answers? All right. I would say if I was a little kid, I would say I want C because it's taller and it's going to hold more soda. Because when I was a kid, I was always wanting the taller cup because I thought it would hold more soda. Right? That sounds
Common mistakes.
Sounds good. So what about the middle one would make you say it would hold more? Most of you said B. So tell me why you think maybe B would hold more. Josiah. You raised your hand.
Can I?
Hang on just a second. Josiah, you raised your hand.
All right. I think it would be C because it's super tall, and I would like to have, my drink in there.
Okay, and do you notice that C is more than twice? Okay, you did that, right? That's exactly right. Do you notice that C is more than twice as tall as B?
Yeah.
Okay, and does C look like it would have as big a base as B?
No.
But it's twice as tall. So that's exactly what I was wanting somebody to say. Thank you, Josiah. Izzy, I think you asked about talking about B.
I actually wanted to agree with Malice because imagine if like this was a 3D image and something came down and squished these and smashed these into like a thinner or shorter piece, then I thought that it would be about the same. That it would grow to be about or shrink to be about the same.
Give me just a second.
So, like,
hey, Izzy, hold up.
That's not depressing at all.
Okay, go ahead.
So like if that was made of dough or something, and it somehow miraculously kept its shape, or its main shape as you smushed it down, that it would
have extra at the top.
Yeah.
Can everybody see who's annotated on here? There's a great argument for C. They're saying, okay, let's say this is 13, the height of this. Here's another 13, and there's a little extra. And let's suppose that this surface base is about half as much as this one, but it's more than double in height. That's a great.
Well, someone could also argue that A could be that, because A is like a lot more skinnier than B. Because B, it's like skinny or whatever. It like looks half of that.
Agree. So here's the thing. Unless you know the actual diameter of all three circles, there's no way to know that. Because you all can argue the heights right now. It appears that B is a little more than double the height of A, and C is a little more than double the height of B. But it's all about knowing the diameter of the base of the circle base. Because here's the reason why. If I'm multiplying the the base times the height, the bigger the base, the more it's going to add up as I go up height, correct? So my whole point here is looking at the height is going to not be the only determining factor. You have to also know the actual base diameters of the circles. That's going to be super important. So yeah, good discussion that you all said that, because you could argue all three of those from this picture. So good job. All right, let's move to the next one. Really quickly, notice a couple things on here. That a regular cylinder that looks like a coffee can or a soda can in the middle here, it has a name. You might want to write this down. You've probably never heard this. Those are called right cylinders. What that means is that the cylinder is perpendicular to the base. All right. Notice over here, it's not. Okay. So the only thing that would happen differently here is that I would have to get the literal height from the table up instead of going down its actual side. Y'all see the difference? That's no different than when we're doing triangles, right triangles versus other kind of triangles, right? So I just wanted to point that out, that is a difference. That is not a 6th grade skill, but that's something I wanted you to know. Okay, if you will send me on the Pear Deck, what does the R stand for and why is that important? What does the R stand for and for what is that important? All right, great. You all are saying that the R stands for radius. And that's important because the radius is what you have to use to calculate the volume of the cylinder. That's exactly right. Ashley said you have to have that to actually calculate. Okay, so let me give you a couple of pieces of information here. Okay, if I go across, okay, so if you can pay close attention to this because this is where kids are confused often. Okay, if I take, I'm in the middle one here. If I go across this cylinder, this circle like this, okay, that's the diameter. Let me move that over.
Don't you need the diameter to find the area?
Hang on.
No.
No, you don't. Okay, so that's the diameter. Here's why the diameter is important. And you might want to take a screenshot of this in just a second. The diameter is pi to the circumference. Okay, the diameter is pi to the circumference. That means across the circle in the middle. The diameter has to hit through the center point of the circle. Has to first be a real circle. It has to go through the center point of the circle. When it does, that length is 3.14 as much as if I take and go around the circle. So around the circle is 3.14 times as much as going straight through the circle would be. That's the whole reason we have the idea of pi. Pi is the relationship. It's literally a ratio of diameter to circumference. So diameter is 3.14 of the circumference, or circumference is 3.14 times as much as the diameter, right? So that's the only time you're going to use diameter. What diameter is important for, though, is that radius is half of the diameter, right? That's important. The radius is always half the diameter. But here's what you got to know about the radius, okay? The radius has to be, the definition of a radius is not half the diameter. The definition of radius is a line segment from the center of the circle out to the edge. That's what radius actually means. It's from the center point of the circle out to the edge, which just so happens to be half of the diameter, right? And I got to know that when I'm calculating the area of a circle, all right? So next up, will you text me on this screen, on this one, what is the area to find the, what is the formula for finding the area of the circle? That's the base. Because I'm
just the circle?
For the circle. How do you find, what's the formula for finding the area of the circle? Okay, some of you are getting it right. Remember, it's the joke about pies being square. That's the formula we're remembering here. All right, so several of you are saying that the formula is area of a circle is pi times radius squared, which is correct. All right, so if that were to be said, let's look at the next one here. What would be the area, what's the area of the base of this circle, of this cylinder? What is the area of the base? You do 9 times pi. 9 times 3.4. 9 times 3.14. 28.26. All right, so if you are telling me that it's 28.26 square inches, that is correct. Now, if I want to get the volume, I'm going to say area, which happens to be 28.26 times the height, which in this case is 10. So the volume is 228.6, excuse me, 282.6. right? Because I just moved the decimal one. All right. Cubic inches. All right. Again, if that's not clear, we're going to do one more. Today, we'll do some more tomorrow. Please text me and I can help you individually if you need help. I'm happy to do that, okay? Here's another one. Will you try this one by yourself? Give me the volume of this cylinder. That'll be our last one for today.
Ouch, my ears.
Wow. Grab your ear. Somebody's got a loud keyboard.
Click.
By the way, guys, whenever we do get back to school, even if it's not until 7th grade, I will have rewards for you guys for coming and doing this every day. Like I've said before, I promise you I won't forget it. I appreciate that we have almost everybody in here. We have got 20-something kids in here out of our 25.
Yeah.
Makes me happy that you're here. We'll do some kind of a field trip to celebrate working through the quarantine.
Cool.
Working through the quarantine. Field trip.
Yeah, we'll do something to celebrate as a reward for you joining in.
Mr. P?
Yep.
Do you still get paid?
Yep.
Okay, what if once all this really bad corona stuff is over, and like places are still are open again, we can go to like that trampoline park again?
Yep.
Like, you know how we did that?
Yep. And let's say, yes, I think that's a great idea. But let's say you haven't always been doing everything. If you start now, I'll still include you in the sticking with it. So is it. Please. Important. That way you're going to be ready for 7th grade. All right. So most of you said that it was 24,501 and 42 hundredths cubic meters, which is correct. So let me try to clarify. Okay, so it's literally like,
Mom said,
okay,
you
it's
make
literally
breakfast weekends. I make breakfast on weekdays.
But you just make breakfast on the weekday.
All right, so it's literally like, I had to mute the thing. Okay, this bottom level is a layer of cubes, and then there's literally 27 layers on here, right? It's just layer after layer after layer after layer, 27 sets of that. That's all it is you're doing, okay? When you're doing that, okay? So that's where we stop today because the Zoom's almost up. Okay, please try your best to come back for the GIM kit this afternoon. We had 2 of the top 3 on the platform, and we want that again today, right? We want to be in the top 3. I said to somebody,
we'll do it, guys.
we had 2 of the top 3, but we're only 1/7 of the 6th grade. So that was pretty good.
I didn't get to come here. I didn't get to come to the Gim Kit yesterday because I accidentally missed it. I was doing other stuff, but I saw the video.
Yeah.
That
Okay.
was a lot
today,
of people.
though. Come today.
I am.
All right.
It's going to be now or at 2.
Bye,
It'll be
everyone.
day
Right.
2. Hey guys, don't forget, get your parents ready for Friday. Friday at 11:30 after our regular lesson. We'll pay
I've got my dad.
Do you know what the lesson is going to be for that one?
Oh, let's vote. Everybody send me a text of what you want the subject. Do you want science, social studies, math, or literacy?
What if we did it on a book that we've read, but the parents haven't?
Well, that wouldn't be necessarily fair.
Wait, they're not going to do Gim Kit, are they?
So if you will send me your subject choice, and then we'll go with
everyone math, because my
okay?
mom always gets math wrong.
All right. Anybody got a question?
I'm pretty sure everyone's parents.
Bye.
Okay. See you guys. Bye.
Bye.
I knew what just happened.